Welcome to lesson number 3. We're going to look at calculating the length of a side in right triangles. First, we're going to review the Pythagorean theorem. So the Pythagorean theorem can be applied in any right triangle. And so usually you've seen it as c squared is equal to a squared plus b squared. Sometimes you'll see it written like this: a squared plus b squared equals c squared, where c is the length of the hypotenuse and a and b are the lengths of the legs of the triangle. So the sides of the triangle that extend originating at the vertex of the right angle. So A, B, and then C is always your hypotenuse opposite of your right angle. Now, depending on what you're looking for, you can rearrange Pythagorean theorem to be a squared is equal to c squared minus b squared, or b squared is equal to c squared minus a squared. So if I'm looking for a side length, a or b, I would just have to subtract the other side length from my hypotenuse. So let's take a look at these two examples where we need to calculate the side lengths using Pythagorean theorem. So here I have my hypotenuse, which I'm looking for. That's my unknown, which is x. And so if I use my Pythagorean theorem, this is equal to c, and I can kind of arbitrarily assign this to be a and b. So I would say that a squared is equal to, a squared plus b squared is equal to c squared. And I would say that 2.5 squared plus 3.7 squared is equal to c squared. Now, if I square those individually, I get 6.25 plus 13.69 is equal to c squared. So 19.94 is equal to c squared. But that gives me the value of c squared, not the value of c. So in order to get the value of c, which is the side length, I would have to square root it. So square root 19.94, and my value of c to the nearest tenth is going to be 4.5. So x is equal to 4.5 centimeters. Now, I want to complete this triangle, find the third side. I'm going to call this side x. Now this time, that's not the hypotenuse, right? This it doesn't really matter which angle we're using. And again, the only thing that's important to label with the Pythagorean theorem is your hypotenuse. So this is going to equal c. And again, we could say this is a, which means this could be b. And it's pretty arbitrary as to whatever we choose to label. Now, the version of the Pythagorean theorem we're going to use is we're looking to find b this time, right? So we're going to use this version. And if you're confused about which one to use, you can always set up your equation the regular way as a squared plus b squared equals c squared. But if I'm trying to isolate b and find b, then I'm having to bring a to the other side, which is why this becomes minus a squared, because I got to subtract it from both ends of my equation in order to have my balanced equation. So b squared then is going to be equal to c squared, which is 122 squared minus 120 squared. Now I can do this in one step on my calculator, but I'm going to do it in two. So using brackets, I'm going to go 122 squared minus 120 squared. This gives me 484. Now that's not the value of side b, or x in this case. Remember, in order to find the value, we have to square root both of them. So you've got to take the square root of 484. So square root of 484, and I get an answer of b is equal to 22 millimeters in this case. So that's my final answer. Now, this isn't using trig ratios, right? This is using Pythagorean theorem. We can also find the same information using my trig ratios. So in the right side over here, I have a right triangle ABC, and I'm given the length of one side as well as a measure of an angle. So the procedure for determining the length of the side X is going to be shown below. So the given side, which is 14.2 centimeters, happens to be the hypotenuse, right? So there's my hypotenuse. And the side to be determined X is opposite to the given angle. So here's my angle here, and this is the opposite side. Now, if I have the opposite side and the hypotenuse, if I look at my mnemonic SOHCAHTOA, then I have an opposite and a hypotenuse. So the ratio that we would pair with the opposite and the hypotenuse is my sine ratio. So I need to use the sine ratio. Now, when we write this, this would be written as sine 52 degrees is equal to opposite, which is x, over hypotenuse, which is 14.2. We would then cross multiply to get, so multiply 14.2 up here. So 14.2 times sine 52 is equal to x. To one decimal place, and so in my calculator, 14.2 sine 52, close my bracket, to one decimal place, the value of x is equal to 11.2 centimeters. 11.2 centimeters. Now, let's look at this example. So caribou jerky, a traditional Inuit food, can be seen drying on wooden racks along the shores of the Arctic Ocean. So a piece of wood 2.8 meters long that can be used to build a drying rack rests against a wall. So we have a wall here, and then I have a piece of wood, and this piece of wood is 2.8 meters long. And it's against the wall. So here's my wall. And the angle between the piece of wood and the ground is 40 degrees. So that's 40 degrees. Make a rough sketch, check, and determine the distance between the bottom of the piece of wood. So the bottom of the piece of wood, which is right here, and the bottom of the wall to the nearest tenth of a meter. So we're looking for that value x. Now, again, we need to refer to SOHCAHTOA here and think about the information we have. I have my hypotenuse. This is my 90-degree angle. I have my hypotenuse. And I have my side adjacent to my angle. So I have my adjacent side. Now, adjacent and hypotenuse means I need to use cosine. Cosine 40 degrees is equal to adjacent, which is x, over hypotenuse, which is 2.8. In solving for x, all I need to do is cross multiply. So multiply both sides by 2.8, which would give me 2.8 cosine 40 degrees. My value of x then is equal to 2.8 cosine 40, which is to the nearest tenth of a meter, 2.1 meters. Now, what we want to do is determine the height of the wall in the above example using trig ratio and using the Pythagorean theorem. So first of all, I want to know the height of the wall. So from this point to this point, I'm going to call that y. All right, so in order to find out y, if this is my angle, that's the opposite side. So the opposite side is right there. Sometimes it's good to store these answers, so 2.1449, and you might see what happens if we don't store that answer and use my rounded decimals. But using my trig ratio, that's the opposite side. I have my hypotenuse, so that would become sine 40 is equal to the opposite side, which is y, over the hypotenuse of 2.8 meters. And then I would cross multiply, so 2.8 sine 40 is equal to side y, and side y is equal to 2.8 sine 40 to the nearest tenth, 1.8 meters. 1.8 meters. Now, using the Pythagorean theorem, a squared plus b squared equals c squared. I'll call that b squared that I'm looking for. The height would be the hypotenuse. Subtract one of the side lengths. So let's go with b squared is equal to 2.8 squared minus, let's go with this side, 2.1 squared. 2.1 squared. All right, so 2.8 squared minus 2.1, I should put that in brackets, minus 2.1 squared is equal to 3.43. And then we need to take the square root of 3.43. So second function, square root 3.43 is equal to my value of b, which is 1.8 meters. Now last, I'm going to just do fill in this, and then I'll do, I'll try to do this question in an appropriate amount of time, but in the previous work, the side which had to be turned was in the numerator. So sometimes it's going to be different, like here. Sometimes it's the denominator, and that changes things a little bit. So in the diagram, this time here's my angle, and I have my hypotenuse and my adjacent side. So adjacent and hypotenuse, again, if we use our mnemonic SOHCAHTOA, adjacent and hypotenuse means we need to use the cosine ratio here. So cosine 64 is equal to 7.9a. We'd have to cross multiply to get a times cosine 64. But we need to solve for a, and so I'd have to divide both sides by cosine 64. When I do that, I would get a is equal to 7.9 divided by cosine 64. So to the nearest tenth, 7.9 divided by brackets cosine 64 is equal to 18.02. To the nearest tenth, we're going to say 18. Now in this example, we want to determine to one decimal place the length of the hypotenuse of triangle PQR, in which angle PQR is equal to 90 degrees. So this is 90 degrees and this is Q. Angle PRQ is 28 degrees. So Q, PQR. Angle PRQ is 28 degrees. So this angle here is 28 degrees. And PQ is 15.6 millimeters. Now, what I want to determine to one of is the length of the hypotenuse. So we're looking for x there. So if I have x, I have my opposite side. So I have my opposite and I have my hypotenuse. That means we need to use sine 28 degrees is equal to 15.6 over x. The first thing I need to do is cross multiply to bring x to this side, giving me x sine 28 degrees is equal to 15.6. But then I got to divide by sine 28 on both sides of my equation, giving me x is equal to 15.6 sine 28. So 15.6 divided by sine 28 equals 33.2. So x is equal to 33.2 millimeters.